A train standing at a stationary yard blows a whistle of frequency 400 Hz in still air. The wind starts blowing in the direction from the yard to the station with a speed of 10 meters per second. What is the frequency, wavelength, and speed of the sound for an observer standing on the station platform? Is the situation exactly identical to the case when the air is still and the observer runs towards the yard at the speed of 10 meters per second? The speed of sound in still air can be taken as 340 meters per second. As the speed of the wind is given and the speed of the sound in still air is given. Effective speed with which the wave reaches the observer would be 340 plus 10, as the wind is moving towards the yard. That will be 350 meters per second. There is no relative motion between observer and the source. Therefore, the frequency heard by the observer would not change. Therefore, the wavelength would be velocity by frequency, that will be 0.875 meters. The above situation is not identical to the case when the air is still and the observer runs towards the yards, as there will be relative motion between the observer and the source, and the frequency of the observed would change as V naught is equals to V plus minus V naught divided by V plus minus Vs multiplied by the frequency. The frequency as heard by the observer would be V naught is equals to 340 plus 10 divided by 340 into 400. That will be 411.76 Hertz. Therefore, the wavelength would be 340 divided by 400. That would be equal to 0.85 meters.